All right. Good afternoon. We are going to do this lesson today on solutions and molarity. So I think that's the question that was probably being asked that you wanted to go over. So that's what we're going to try to go over today. Rhodesia was supposed to join us. Hopefully she gets on soon. We have some preliminary questions though to start us off, just to get us thinking about solutions and things that we need to be concerned with today. Where is my, so what is osmosis? What is, what is
I am not sure.
okay. All right, so osmosis is how water moves in a solution. It moves from something of higher concentration to of lower concentration. So that's the movement of water. So for instance, if I have um, a solutions that I'm mixing together or that are next to each other, and one is, oh, sorry, turn on my annotate feature. One is less salty, or this area of the solution. One area of the solution has more salt, like this is salty, and this one has more water in it. The water is going to diffuse or move in this way towards the place that has less salt, right? So water always moves um, to a place of high concentration to low concentration. That is osmosis, is high to low, right? In general, water is going to move, and that's just the movement of water, right? That's what osmosis is. It's just the movement of water from high concentration to low concentration. Diffusion is the tendency of any liquid to move from high concentration to low concentration, right? That's what that movement is. High to low is diffusion. In general, for any liquid or gas, you're going to move from high concentration to low concentration because liquids and gases like to spread out as much as possible. And so how are osmosis and diffusion different? The idea here is this: osmosis only deals with water, and diffusion can be talking about any other gas or liquid, right? Um, and when we're talking about concentration, in general, we're just talking about how much non-liquid, right? Or how many things we're dissolving into a liquid. So if I just keep adding more and more salt to water, it becomes saltier, right? So the concentration of salt is higher. If I add just 1 teaspoon and I stop, my concentration of salt is low, right? So concentration talks about how much of something we are trying to dissolve into a liquid. So how much are we putting in? That's concentration. And I think the question that you had to explore on your um, GD Ready was involving solutions and molarity. And so that's what we're going to talk about today, like how that concentration or those things play into finding solutions. So on your GED science exam, there's always going to be 1 or 2 questions where you have to use a formula. And the idea here is about practicing to use formulas and not necessarily knowing the ins and outs of the formula. But today we're going to talk about the ins and outs of this particular formula because I think it's helpful in manipulating the formula. We have to know what it's talking about. All right, so this molarity formula has to do with concentrations and solution. And so we're going to talk about that today. And there's a ton of notes that I already organized for that. Um, and it's not a fun topic, I will say that right away. It involves a lot of numbers, um, but hopefully we can get a pretty decent understanding of it by the end of our time together. All right, so let's try it. I'm going to go into Schoology. I'm actually going to go into our science folder in our GED prep course on Schoology. Because that's where I put this information for today. All right, so you go to your GED prep course, you have to scroll all the way down to the orange science folder. And within that folder, we're actually going to go all the way down to the last folder in there, which is called Solutions. And inside of Solutions, what we're going to start off with is the Molarity and Other Solutions notes. That's what I'm going to open up right now. Right, so this is going to give us a quick overview of what molarity is and how we use it, and just some important definitions. I'm not going to walk through every single definition and thing with you, but just the ones that are going to prove important to what we're discussing today. But molarity, again, measures the concentration of a substance, but we are using the moles of that substance. Do you know what the moles are of a substance? Have you heard that chemistry term before? What the moles are, or how to
I've
without
heard
using?
it before, I just don't remember.
Okay. Yeah, so that's where it gets complicated because molarity uses the moles of something. And I really hate that word and that term. But when we're talking about the moles, we're talking about having to use the periodic table to find the atomic mass. And that's what we have to use when we're talking about these solutions. But we'll get there in a second. That's why the periodic table is also in that folder, because it involves all of that. So it's like the most sciencey math topic in the world is more, it's like you want to take like advanced, like slightly advanced math and annoying chemistry, and you combine them together, and this is what you have, is the molarity. I remember absolutely hating this in high school, but it actually is not too terrible. But I remember just being like completely defiant when learning it. I was like, I don't want to learn this. This is terrible. All right. So your solute and solvent are the two important words we're going to be looking at today. And your solute is a substance that is dissolved into a liquid solvent. And your solvent is the liquid component that the solute dissolves into. So to simplify that just a little bit, if I am making salt water, right, that is my solution. My solution is called salt water, right, because it contains salt and water, right, very simply. My solute in this case is the salt, and the solvent is the water, right? Just that simple. Um, but my solute is the thing that I am dissolving into my solution that is that liquid to make the solution, right? Your solution, right, is a combination of two things, um, two discrete things that become one, right? I have salt and I have water, and now I'm putting them together to make salt water, right? The important thing about a solution is that you can not only make it by combining those two discrete things, but you should also be able to then separate them out later, right? And there is a process by which you can separate salt from water, right? Desalination, but it takes a lot of work, but you can do it. That's the important part of like what a solution really is. A solution, you have the two parts, they're together, right? And we can also separate them. When you can do that, you're talking about a heterogeneous solution. I'm sorry, a homogeneous solution. So salt water, already making clerical errors here. A salt water would be what is called a homogeneous solution. a solution that appears uniform throughout. I cannot, looking at salt water, pick out the salt from the water, right? It's all together, it's in one system, it's homogeneous, homo meaning same, right? They are the same solution. A heterogeneous solution is a solution where I can obviously see the two distinct parts, right? An example of that would be oil and water. I can try to mix oil and water together all I want. I can stir them up, I can shake it up, I can mix it. It'll be fine for like 5 seconds, and then they will slowly drift apart from one another, right? That is a heterogeneous solution. They might be together in the same container, but they are in different layers. I can distinctly see the oil from the water. The oil is always going to sit on top of the water because it's less dense than the water, right? So that is a heterogeneous solution. So we have two kinds of solutions, but they both have solutes and solvents. Whatever you're trying to dissolve in the other is a solute, and the thing that you're trying to dissolve it into is the solvent. All right, so how do we measure these quantities, right? We measure how much solute is in a solvent with this term down here, molarity. I'm just going to scroll down so that we have this equation. This is the equation that we're going to be working with today. Is this molarity equation. And you can see that molarity, this tells us what it is. It's moles of solute divided by the total solution volume in liters, right? This is important because we'll get our measurements sometimes in milliliters or in other measurements, but in order to put it into the formula, we have to convert it to liters. So just to practice this idea, if I have 125 milliliters, how many liters is that? How do I convert from milliliters to liters? How many milliliters are in a liter?
You will have to see how much 1 liter is.
So the conversion for liters to milliliters, right? I'm gonna write my chart on here. So liters are in the middle, right? And then I have another measurement here called the deciliter, and another measurement here called the centiliter. And then at the end, or not the end, but towards this end is the milliliter. There are other measurements after it, but I don't really care about those as much. Of course, there are other measurements that are larger than the liter as well. But the spaces, 1, 2, 3 spaces that there are between liter and milliliter describe the movement of my decimal point, okay? All right, I'm either multiplying by 10 or I'm just adding another decimal point, right? To get from liters to milliliters, I'm multiplying by 10. To get from milliliters to liters, right? To go from the smaller measurement to the larger measurement, I have to divide by those 3 tens. So it's a division by 1,000 or a movement of my decimal point 3 times to the left. 1, 2, 3. Okay, so 125 milliliters is the same as 0.125 liters. So this is metric conversion, right? So the metric units use tens. And in science, we use the metric units because they use tens, and it's easier and simpler. And so to go from milliliters to liters, I'm dividing by 1,000, or just moving the decimal place 3 times to the left. Okay, that's how we go from milliliters to liters. And so I'm going to actually pause here for a second, and let me try to find a document here for metric conversion. Mm-mm. Okay, let's try that. All right, so this is my metric conversion chart that shows me the whole chart from kiloliter at the extreme left end,
I can't
hectoliter.
see that. It's still on the
Oh,
same.
sorry, there it goes.
Thank you.
So kiloliter on the left, hectoliter, deciliter, and then in the middle is the unit, either meters, liters, or grams. And then I have deci, centi, milli. All right, so that's how this conversion works. And I'm going to also add this to that folder so you have that as reference. But I divide by 10 as I go to the left, which is what this arrow at the bottom tells me, and I multiply by 10 if I'm going from the left to the right. Right, this is just a good tool and a good handy reference thing when I'm converting within the metric units. Okay, so if I have kiloliter, hectoliter, deciliter, liter, deci, centi, milli, those are my prefixes for the liters and the units. All right, so this is a good descriptive chart as well. I'm gonna go ahead and add that right now to our storage page. Let's go there. Okay. Okay, so now we're back to this molarity, right? So this is what we use to prepare solutions and then figure out the different concentrations, right? So a certain molarity will tell you the concentration, right? We use the moles of solute over the total solution volume in liters. Um, and let's look at an example here. So it says I have 20 grams, and you can see this, right? 20 grams of sodium hydroxide.
Yes, I can see.
Okay, is dissolved into water with a total volume of 1 liter. What is the molarity of the solution, right? Um, so I have to find the number of moles that are present in 20 grams of sodium hydroxide. So first and foremost, I have to know what sodium hydroxide is, right? On your SciEx exam, they're going to call it by a name, but then they're also going to show you the chemical symbols. So you will see that it's NaOH. So you don't have to go around learning these, which is very lucky for you because I had to learn them and it was annoying. So sodium hydroxide, right? And then the other thing you're going to have to do now that you have the name of it, you're going to have to use your periodic table to figure out the atomic weight of each of these elements. You have to add them together. All right. So you need the atomic weight of Na plus the atomic weight of O plus the atomic weight of H. Right. And we add those all together and we're going to need that for our equation. So you have to use many reference tools when looking at molarity. So unless it's given to you. Sometimes they're nice enough to give you the measurement already, but you have to look each of them up. So what that would involve is pulling out your periodic table. So in the same folder, we have a periodic table. Right? And I would just open this up and I would look for those measurements, right? For Na, for O, and for H. And so if I make this larger, just a little bit, I can find my measurement for Na here. It's 22.98. I'm going to say it's 23. I can find my measurement for oxygen, O, right over here. It's 16. And then my measurement for H is just about 1. All right, and I'm going to add those all up together, right? And I'm going to get 40. Those are my grams per mole. That's how much this weighs in general. I'm going to use that information to help me in my equation. I'm going to exit here, go back to my notes. All right, so I have my sodium hydroxide and I've measured how much it weighs. Right, so I need this information, I have it, and I know that I'm going to put 20 grams of it into a solution. So how many moles is that? Well, if it's 40 grams per mole, I'm going to do 20 grams times 1 mole divided by 40 grams per mole. So it essentially ends up being 20 divided by 40, which gives me half a mole. Right, which is what we have here. I have 0.5 moles of NaOH. Okay, and I'm going to dissolve that, it says, into 1 liter of water. So the amount of water I have is the solution volume in liters, which happens to be 1. I have half of a mole. So half a mole divided by 1 is not going to change anything. It's just going to mean that I have 0.5 molarity NaOH solution. All right. So there are several steps to these molarity problems. That's usually why that's why there's usually only 1, maybe 2 of each kind of formula question on the science test, is because these are very specific and very mathy. They just want you to be able to demonstrate that you know how to solve using a formula, right? And so those steps that I did again were to calculate the grams per mole, right? This is where you use your periodic table. Okay. Next, I have to figure out the number of moles, right? And in this situation, you take the grams that you're given and divide it by your grams per mole. Okay. So how you do that is you take your grams and you divide it by grams per mole. And then step 3 is you plug all that rest of that information into your molarity formula. You use your molarity formula. Right? That's one way. So sometimes that's the way to do that, but they also might ask you different questions using that same molarity formula. So we're going to look at different questions that they can ask you as well. We're just going to scroll down here in our notes. Okay. Um, so this question, it says, how many moles of anhydrous and anhydrous copper sulfate, thankfully they give us that chemical formula, are required to make zero point 0.5 liters of a 0.25 molar solution, right? So we're trying to figure out the moles of copper sulfate. They give us the amount of liquid and the molar solution, right? We have to remember that this is our molarity equation, right? Molarity is equal to moles over liters, right? So if I'm given the molarity, which is that number there, and I'm given the liters, right? I can figure out the moles. I just need to rearrange this formula a little bit, right? So now I'm going to multiply liters times the molarity to tell me the number of moles. All right, so I take the 0.5, multiply it by 0.25, and I end up with 0.125 moles. Make sense?
Yes, this one wasn't that bad.
Yeah, this one is a little simpler, less steps, right? If they give you like, hopefully this is the kind of question you're looking for, right? Where they're just like, oh, you want me to rearrange a formula? Got it, right? When you have to do those several steps, like the one before, you're just like, I might skip this question.
Yes, and that was the first one, and I'm just like, oh. But
Yeah,
that's when they shut down and they started messing up. So I'm just like, maybe that was a sign to just, I'm gonna wait for that one. Because I
yeah.
was just like, oh no.
Yeah. So I mean, honestly, like if the question seems too complicated, because there's really only going to be one or two of these on the test, and the rest of the test is really straightforward, feel feel free to really just skip that and be like, you know what? I saw this, and even though Mrs. G kind of walked me through this, let me just go ahead and skip this. And then if I have time, I'll come back to it and like do the things that make more sense. Because at the end of the day, like the 6 points that you might lose for not answering that question is not going to be worth it if you answer the rest of the test well. But if you spend 25 minutes getting that one question right and then miss half of your test, that's not worth it either, right? So
I'm just
just
like,
use your time
what?
wisely and just kind of like come back to it if you can.
Yes, because I was just like, what? I was so stuck.
Okay, let me scroll down. All right. Another example, it says it's asking us for how many liters of water would be required to prepare a 0.75 molar solution of sodium hypophosphite with 0.45 moles. So again, this is another rearranging question, right? Because the molarity equation, which is what it'll give you, right? It'll give you the molarity equation and tell you what the molarity equation is, but then ask you for something like the liters. Okay, trying to find the liters, what you're gonna need to do is move the liters to this side via multiplication, right? So now you have liters times molarity is equal to moles. But you still want to get the liters by themselves. You have to divide both sides by the molarity. So to get your liters, you just have to do moles divided by molarity. And so they've given you the moles, they've given you the molarity. So do 0.45 divided by 0.75 to get zero point 0.6 liters, right? Most of these questions on the science test is going to be about rearranging the formula, not necessarily using the formula straight up, but I do have to give you both practice just in case they do ask me that. Right? Most of it's going to be something like the last two that we've seen, which are pretty easy. It's like just rearrange the formula and solve for it, not do all those steps to get this one answer. Right. Let's see. Okay. Normality is not really asked that much. Percent by volume, that can be asked as well. And this is just the information on how you find percent by volume. So it's just the volume of the solute divided by the total volume of solution times 100 because it's a percent question. Um, so this will be given to you, something like this will be given to you. You just have to multiply by 100 essentially. So if the question is something like 10 milliliters of isopropyl alcohol is added to 90 milliliters of deionized water, what you have to remember here is to do that addition, right? Is to add the 10 to the 90 so that your total at the bottom is 100. That's the step that everybody kind of forgets. It seems super simple, but you want to rush through and you'll be like, oh, 10 divided by 90 times 100. And it's like, oh, how did I get that one wrong, right? You just didn't add it together. You have to make sure you add together because the equation is total solution volume, right? And the total includes the 10 that you're adding. And that's really the piece that people forget often, right? So just make sure that if you see a question like that, always remember or hear me in your head telling you to remember that it's the total solution. So make sure you add that, you add this number, this 10 to that 90 to give you 100 milliliters, okay? The other thing to be careful of is they might put one of the measurements, like they might say 0.9 liters and you're adding 10 milliliters. Don't add it and come up with 10.9 liters because that's not what you have, right? Make sure you are working in the same measurements because that's what it'll also try to trick you. So if you have 0.9 liters and you want to work with milliliters, make sure you convert that to milliliters, right? So you're actually working with 900 milliliters, right? Something like that. Like just be very careful because they will do stuff like that as well, where they'll give two different measurements and be like, oops, did I trick you? Yeah, they purposely were trying to trick you, right? So be very careful, make sure you're working with the same measurement. It doesn't matter in this equation that you work only with liters or only with milliliters. You just have to make sure that both measurements are in fact the same, because that will throw it off. I have not seen a lot of percent by mass questions on the test, but this is the same idea, right? Make sure that you're combining and making sure that you're working in the same measurement, grams and grams, kilograms and kilograms, not in two different weights. So the same thing that we were doing before. And of course, yes, your concentration is always mass of solute over volume of solution. All right, molarity is in there. We just did that. Yeah. All right. So yeah, these notes are just like in general, very helpful, good summary of some of the different equations that you might have to work with when you're working with different concentrations. This is a good summary of those types of formulas. All right. In your practice folder, just do a couple, we'll just do a couple together and call it a day. But we have here this molarity practice number 1. This is what I'm opening right now. All right. What is the formula for molarity again?
Mole over liter.
Okay, great. Moles over liters. Perfect. I'm going to write that in so I don't forget it. Moles of solute, of course, right? Over liters of solvent. Okay. So what is the molarity of a solution that has 5 moles of NaCl and 10 liters of solution? All right. So this one is very straightforward, right? Because I'm not given the grams, I don't have to turn it into moles, right? I'm given the volume in liters, so I don't have to change. I don't have to change from one thing to another. So I just plug it in. Just 5 moles over 10 liters, which gives me what?
2 liters.
0.5 m. Right?
Oh, I did it backwards.
You did it backwards, you said?
Yes, no, I did it backwards. I did the
Oh,
10 into the 5, not the 5 into the 10.
right. It's 5 divided by 10, right? So it has to be half of a mole. Yeah. Mhm. Follow what you've written. That's why it's important to write the steps down, right? That you can visually see it and be like, what mistake am I making right now? Yep. Yeah. Okay. All right, so this one requires more steps, right? Because it says, what is a molarity solution that is 10 grams of silver nitrate is dissolved into 500 milliliters of solution. So what do I need to do? Well, step one says if I'm given grams, I have to turn it into moles using the molar mass. So that means I have to take my 10 grams and divide it by the grams per mole, but I have to find that by using my periodic table. So I have to find my measurement for silver, for nitrogen, and my measurement for oxygen as well, and add all 3 of those together. Well, I have to multiply this by 3 first, because I have 3 oxygen. Right? So let's go through those steps, those annoying steps. That means I have to go and pull up my periodic table. I have to find Ag, which is silver, and I see
47.
that it's about 100.9. I'll just use that measurement. I'll use 100.9. 100.9. This is right. 100 and, sorry, 107.9. This is the measurement for silver right here. 107.9. The measurement for nitrogen is 14. And for oxygen, of course, again, it's 16. 16 times 3 is going to be 48. Now I can get out of here and go back to my assignment. So I have to now add together these 3 measurements, 107.9, 14, and 48. So I have 169.9. You will have a calculator for this part of the test. So I can just do 10 divided by 169.9. So I have 0.0589 moles. I'm going to divide that into 500 milliliters of solution. I have milliliters, but I always have to use liters. The term milliliters into liters, I have to move it my decimal point 3 places to the left. So 1, 2, 3. I'm going to divide this by 0.5 liters. So that my molarity is 0.118. In
So
science, we're
we
going to do
only
like
go
3.
3, right?
I'm sorry?
Yep. So we stop at the third number.
Yes, that's about to say, yeah. In science, you always want to make sure you have about 3 significant figures when it's not an even number. Yep. So 0.118. Yep. Good. It's my molarity. All right, I'm going to clear this. Move this up. All right. All right, and so for number 3, I'm going to let you work through this one for me. What do I do here? How many moles of sodium chloride are needed for 1 liter of a 0.5 molar solution?
So don't we have to figure out how many is in there first
Okay, so
from
it
the
wants us to
tables?
figure out the moles of NaCl, right?
Right.
What's our equation for molarity again?
Mole over liter.
Okay, moles over liter. And so we're given the liters and we're given the molarity and we have to find the moles, right?
Right.
So what are we going to do?
So we divide the zero. Well, we put the 0.5 on top and the 1.0 on the bottom.
So right now we are given the molarity. So we have
But
that.
we,
We actually have 0.5 is
but not
equal
the
to
mole.
the moles over 1, right? Because we're missing the
Right.
moles. They're asking us for how many moles. So we should rearrange our equation so that we have moles is equal to molarity times liters. And then all we have to do to find the moles is multiply the 2 numbers that we're given. So we have 0.5 times 1,
Times one.
which is just going to give us 0.5.
I was just looking at that too.
Yeah,
I had that written down. That makes sense though.
yeah. So yeah, the biggest thing about these questions is going to be figuring out what it is that they want from us, right? And then rearranging the formula accordingly. So we just need 0.5 moles.
Okay.
Right, let's try number 4. It's a similar question. What do we do here? It says how many grams of hydrogen chloride are contained in a 500 milliliter in 500 milliliters of a 6 molar solution. So again, my molarity equation is here. Okay, it's looking for grams. So what do I need to do?
We have to convert the 500 milliliters into grams.
So we're gonna first have to figure out the moles of HCl. So really when it's asking us for grams, the first step to find grams is to find the moles, right? So that means the moles is what's missing and we have everything else. So we're gonna rearrange our formula the same way we did before, where we did moles is equal to the molarity times the liters. So we have the molarity, right? The molarity is 6.
6.
So we're going to replace the M with 6. And what about for the liters? Do we have the liters?
No, we have milliliters.
We have milliliters. So how do we convert milliliters to liters?
3 spaces to the left.
Perfect. 1, 2, 3. So it's 0.5 liters. So we're going to multiply 6 times 0.5. It's going to give us what?
3.0.
Perfect. So the number of moles we have of HCl is 3. We have 3 moles of HCl. Now here comes the hard part. We have to turn those moles into grams. So the way that we turn those moles into grams is again by using our periodic table. We need to find out how many grams per mole we have. So we have to figure out the weight of hydrogen and the weight of chloride. Well, we know the weight of hydrogen, it's 1. What's the weight of chlorine? So we have to use our periodic table. We go back to it right here. I'm going to find chlorine. Chlorine is number 17 and it's 35.5, essentially. I'm just going to use 35.5 to make my life easy. Just use 35.5. So 1 plus 35.5 is equal to 36.5. So now I have the grams per mole. So the grams per mole of hydrogen chloride is 36.5. I want just the grams. So I'm going to take my 3 moles and I'm going to multiply it
by the
36.5
36.5.
grams per mole. And that's going to leave me with just the grams when I multiply because the moles, these 2 moles will cancel each other out. I have to do 3 times 36.5, which is going to give me what?
109.8.
Perfect. Okay. Wait, 109.5, right? Yeah, this is the 5, 36.5, not 0.8. So 3 times 36.5 is going to give me 109.5 grams of HCl.
Oh yeah, sorry. Right.
All right, 1 second. Okay, back to this. Here this page. All right. I think we have a couple percent by volume, percent by mass questions left in here. They show you how to go through those. If I go back to my main page in my folder, there's also another molarity practice page to do some more molarity work because I think those are the solution questions you kind of had. But yeah, it's kind of just more of the same, and you just want to. I think it's best to kind of just practice it and go through it and review your notes. But that's what molarity is. You have questions about it? If you're speaking, I can't hear you.
What you say? What was your question?
Did you have questions about molarity?
No, not necessarily. I got the formulas down.
Yeah, yeah. It's really going to be a question about rearranging the formula, just being comfortable. So I think just doing some more practice with it is really what would be helpful. Um, and I think that we might try to start keeping Tuesdays for a science day. We'll see. I'm supposed to have more students show up, but also if they don't, I'll just let you kind of decide what you're going to focus on first. But yes, I was trying to rearrange Tuesdays to be a science day and then Thursday math because I had a request for that, but then the other students are not showing up. So it's going to be kind of just wholly up to you on what you want to study. But the plan already is in place for Thursday. So this Thursday, we're going to go over quadratics in quadratic equations because I reviewed your most recent GED Ready, which was awesome. But you seem to be struggling with quadratics and absolute value. Those were some of the two of the main topics that came up. So we're going to do quadratics this Thursday, except it won't be with me. It'll be with a substitute because I have a conference that I'll be at that day. But you will be in good hands to go over the quadratic equations. And they're all my notes and my practices that they'll be using. So it'll hopefully be good information for you on Thursday. And I just recommend definitely using the stuff in the science and solutions folder and just kind of going over some more of those molarity questions and then letting me know if you have any challenges with it. Okay.
Okay.
Yeah, but I'm not going to keep you today. So that's it for me.
Okay. Thank you.
All right, Stacey, have a good one.